got y'all some pointers today. Fixing something right the first time is what keeps mechanics in business. And there's a lot of people out there that have a lot of. I've run into guys whenever I was at the dealer that would. This one guy had like a probably $25,000 box of Snap-on tools that were all brand new and shiny. Didn't have a scratch on them. I don't know where that set of tools came from, but whenever he did anything, he was real sloppy. One day I drew a ticket on a Mustang that he had done some work on. I don't remember why he did some of the regular other work that was supposed to be done, and then they gave it to me for whatever reason. I don't remember why, but when I noticed that he had left one of the EGR solenoid or something swinging by the wires, and I said, "What is this about? You know you're supposed to remount this on its bracket." And he says, "It was like that when I found it." Aren't we supposed to fix things so that they're like they're supposed to be and not leave them like we found them anyway? This is a few little pointers. We're going to focus a little bit on that's what happens when you turn the key on. The PCM, it takes a lot of readings. It looks at barometric pressure. It looks at temperatures, air and coolant temperature. But one of the things it looks at is the closed throttle voltage. That's why it's a good idea to keep your foot off the gas pedal while you're starting the engine. We're so used to no touch starting nowadays that almost nobody touches the gas pedal. But when it sees that baseline reading for the throttle position sensor, that's what it uses to decide when you have let off the throttle. Now, that's an important piece of information that these fuel injection systems just about always need to know. I mean, the earliest ones typically would just have a switch. A lot of the times they wouldn't even have throttle position sensors. They just have a switch letting the engine controller know when you didn't have your foot on the gas and when it was resting against idle. Well, the dash pot function on the carburetor was, and I've talked about this a little bit before, this dash pot was designed to catch the throttle lever when you let off the gas. And when it catches the throttle lever, it lets it back a little bit slower. It doesn't let it slap shut and cause that little dead spot to kill the engine, Now, it's not going to kill the engine every time if the dash pot doesn't work, but occasionally when you decelerate, if the throttle plate slaps shut too fast, the engine drops, and you're thinking, well, it's just a carburetor thing. Why are we even talking about it? But this is a function that has to be there even on fuel injection. It doesn't want it to come back too quick to idle, because if it does, even on a fuel injected engine, it can stall. It's necessary even though the dash pot part is gone. And this dash pot is actually a physics term that's got to do with the viscosity of fluid and stuff, but they call it a dash pot because it actually doesn't. It dampens the return of the right at the very point where the throttle's about to close. It holds the idle up for just a second, then it lets it come down slowly. Fuel injection systems do that too. A lot of people don't know it. Well, electronically is how GM and Ford used to do it. This is what the GM one looks like. They also use this one on some of the Renaults. These are pretty easy to take apart and repair, unless there's something totally burned up in it. But this throttle contact switch was not out here. It was actually built in to the unit. It was a switch that was connected to this, and you could push the end of it and it would have a little movement. And if you happen to have your meter hooked up to this one and that one, on this GM one, you'd notice that whenever you were holding the button, you would have continuity here when you're holding the button. When you release the button, that continuity would go away. Alright, so that's the way those worked. The other two were the motor. See, it needed to know what to do with the motor. If you had let off the gas, it knew it was supposed to start controlling it. It also gave you this dash pot function. When you let off, it would come back down. And typically, and this on the carburetors, it was slightly different than it was on your no-touch starting central fuel injection systems. It had a motor like this on the Fords, and I'll show you that one in a minute. that one would actually, when you shut it off, it would go, it would open the throttle a little bit for your no-touch starting, but it also did the dashpot thing. Well, this is the one that Carter made that Ford used, and these used to cost about $140 when I was at the dealer. One day there was an old man came from a shop out there. He had a Tempo that had one of these on it, and he was given some kind of an issue with stalling or something. And I always like to measure the continuity of that idle tracking switch. You put your finger on the end of this one and you put it, when you release it, it's the opposite of the GM. When you release this one, it's got continuity. When you push it, the continuity goes away. Think of it like a door jamb switch on this Ford one. And I would measure that, and whenever you measured the two switch wires, which would be the purple one and the yellow one, not the red and the black one, you would actually be able to measure that while you were operating that switch with your hand. It ought to have, when you mash that thing, it ought to be wide open and on your voltmeter oil. And when you release it, it ought to be really, really close to 0 ohms. Well, what I would find on these is when I would measure that, it would have like 50 or 60 ohms when you let off. It had resistance on that switch. That would confuse the computer. It could even cause it to stumble when you were taking off and kind of crazy stuff. Most people don't know that. But I fooled with these things for years. They even built me a little box to test them. But anyway, this one here was an interesting one. They also had a relay that was designed, a deep power relay. It was designed for the one that had this on there, that had central fuel injection. And when you shut it off, that EEC power relay would stay energized for 10 seconds. And that EEC power relay would enable keep the engine controller awake so that it would be able to run that idle speed control out a little bit for your next no-touch starting cycle. Now, I actually took some of those relays when we were having problems with Aerostars that were starting hard. I actually came up with a fix by you had to swap the two wires around in the coil cavity, because you couldn't hook the coil up either way on those fancy relays that had the 10-second delay. I would put one of those relays on Aerostars, and whenever you would switch the engine off, you could watch the fuel pressure, and if you had this 10-second delay on the relay, the fuel pump would keep running long enough to where it would run the fuel pressure up to 40 pounds. And that seemed to take a, I don't know exactly what, I don't remember exactly what we found that was causing these things to stumble and to have them be hard to start like they were, even though the fuel pressure was holding good and steady at about 28 psi. If I let it go up to 40, if I put one of the funky relays on it, that's another story I can tell you later. Alright, control and idle air on an MPI. These non-electronic throttle control vehicles have got a port right in front of the throttle plate, and it goes through the idle air control to the other side of the throttle plate so that it can control. Now this one here was on a little Toyota we worked on, and the Ford ones and the GM ones, they cost from $50 to $100 usually, and they work slightly different. This 2-wire IAC valve on these Fords, it uses current to pull this, pop it against a spring, and it depends on how much current it feeds to it as to how much idle speed control it has. So it can move this variable amount. It's not just open or closed. And so if you ever look at the scope pattern of this, it's this crazy looking sawtooth thing. But the more, there's a percentage of current that it gives this idle air control. But this other one, this little Toyota, when we were fooling with it, this little hole here is what I'm talking about. It was hunting, the idle was hunting up and down, up and down, up and down. And I noticed I could reach in here and I could partially cover that up with my finger and I could regulate it. And it turned out there was supposed to be hot water going through that idle air control on that old 85 Toyota. And for some reason or another, there was no water going through it. I had to put a restrictor in one of the lines to force the water to go through that idle air control. But anyway, that's another story. But this is what this thing looks like on the Ford. Sometimes these things will stick and make it hard to start. If it's hard to start, it will no-touch starting. This opens up a little bit to give you no-touch starting too. And if for some reason that little pop it in there sticks, and it's worse on this vented kind than it is on the non-vented kind I got published before here. But see, the air comes in here, the throttle plate is right here. And see, that's how that works. Now on the GM Dodge Jeep, the TBI and EFI systems favored these compact little PCM driven stepper motors, and they basically would send little pulses of current in it. In here is a screw. The motor is connected to a nut that's around this screw. The screw can't turn, but the nut can. And as it turns the nut a little at a time, a step at a time, using a stepper motor, that's what a step's about, this goes out and in. It'll go both ways. And you can see how it's fixed right here. If it retracts, then it lets more air go around the throttle plate. And if it extends, then control the idle. So the more air going around the throttle plate, the faster the engine runs up to a point. And you can see down here, a lot of these, if you took the throttle body off, you can see where that goes through there. And it said I did wash this passage out because a lot of times it gets clogged up with sludge. Just like, they're clogging up around the throttle plate because of the PCV oil steam that floats around in the intake and all that. Well, this one guy came out on his 86 2.3 liter. He was used to the old vehicles. They had carburetors, and he didn't like the fact that this thing's idling too fast when you first started up, but that's cold, fast idle. Come on, hello. And he just didn't like that. Couldn't make him understand. The engine controller was deciding to do that, and I couldn't make any proper adjustment to change it. Now, the wacky thing about proper and improper adjustments is if the EPA people come and find you making an improper adjustment that's not in the shop manual, they can fine you $10,000 as a mechanic and fine the shop too. So this is not anything you don't need to be turning screws and messing around because you think it don't matter, because it really does, although most people will get caught anyway. But I knew about this one case where the EPA guy went to the shop and pulled work orders and found where this one guy had written on the work order that he had made an adjustment to the throttle body that wasn't in the shop manual, and there was a huge fine that shop had to pay, and the mechanic had to pay the fine too, because he did something that wasn't supposed to be done. He violated EPA regulations. Now, this isn't likely to happen to you, but it's best to err on the side of caution. Now, this guy decided he was going to make an air leak to confuse the PCM. He didn't know that's what he was doing, but for some strange reason, he decided to get some thin washers and put them on these bolts. He put them around the bolt, and he made it so that he made a little air space in between the IEC valve, and air was leaking in there. And there is a point at which the engine controller won't even use the IEC if the idle is within this dead band where it doesn't feel like it needs to do anything. So if you've got an air leak that comes from anywhere, and the idle speed is, control motor's not doing anything, you can, which is what this guy made. He made a little air leak right there. What I couldn't explain to him was, you're pulling dirt in there too, man. Well, he was all smug and everything, and he said, well, I figured this out, and Ford couldn't, and so you can tell them they can pay me for my idea if they want to use it, which was pretty stupid with all due respect to that customer. But he wanted to do some little something to make it feel like he had made it his vehicle just like he wanted it to be, He did it, he went about it the wrong way, but you couldn't convince him of that. Well, a necessary function, whenever any of these systems are working right, and GM had some, and Ford too had some idle load compensators. It was a vacuum diaphragm that was extended when it didn't have any vacuum, and it was against the throttle plate lever. And whenever the engine was under some kind of a load so that the vacuum was beginning to fall off, this big diaphragm thing would push that throttle open a little bit until it found the sweet spot where it wanted to be. That's complicated and aggravating to talk about right now. I won't move on here. We want to maintain your engine out during load changes. AC kicks on, using the power steering. It's controlling the idle. And it can do it pretty quickly too. Now, the Asian folks like to use, not all of them, but a lot of the times these Asian idle speed control motors, and this is one from like a Toyota Camry, and they don't typically give a lot of trouble, but the ones that have water going through them, like on some of these Mazdas and all, that idle speed control still fails, and it's like $550. I never really understood why they thought that was a good thing, to run hot water through it and have an electrical circuit. Didn't make any sense at all to me. Whatever, they did that. Back in the old days, for cold fast idle, your old fuel injection systems on German cars particularly had an auxiliary air regulator that had a little bimetal strip connected to a little poppet in there, and it would be open going around the throttle plate. In other words, it would direct air around the throttle plate when the car was cold, and it had like 2 wires going to it, and it would heat up and it would close that. And that was basically an auxiliary air regulator. You can look that up if you're interested in it. Now, where there's a computer, there's a way to learn stuff, and these idle air controls have to learn things. It has to learn how to idle. On some of these Dodge pickups, I don't know if you've ever run this before, I've known of customers that changed a battery on their Dodge pickup and it wouldn't idle when they were done. And it was because they didn't clean the throttle body. The throttle body's dirty. It had learned to give it more idle air control because the throttle body was dirty. And so they would either have to wash out the throttle body or drive it around and let it learn how to idle again. You might remember me talking about that 91 Chrysler that my dad would change the thermostat in it, and it was running just fine after he changed the thermostat because it was running too cold. And he changed the thermostat, and then he changed the oil about a week later. He said after he changed the oil, it wouldn't idle. Well, it had learned because of the, it was running too cold. It contaminated the fuel, the oil with fuel. It was pulling fuel vapor out of the crankcase of the PCV. It had learned to run its fuel trims, which was, in the old days, GM used to call it block learn an integrator. But it had learned to factor in the gas it was expected to get out of the crankcase, and whenever he put fresh oil in there and that fuel wasn't there, it was like a maladjusted carburetor. And he called me real frustrated. He said, all I did is change the oil and it won't idle now. And I said, take the battery cable off for a little bit, clean that throttle body, put it back on, you'll be okay. And he did. But anyway, now, one of the inputs utilized by Ford PCMs for this necessary dashpot function is vehicle speed input. As long as the vehicle rolling, even if the throttle's been released, the idle speed is carefully and deliberately decreased at a controlled rate to prevent potential engine stalls. I actually saw a Thunderbird that was given a problem with the idle because of a speed sensor issue. And that's a one-off that you don't typically ever see anywhere. But you can see right here is when it says on this Ford scan tool, the old new generation Star Tester, it would say part throttle. The IEC would have this percentage that was given that idle air control valve. And see this, look at its RPM, right? Vehicle speed sensor is 16 miles an hour, right? TP voltage is 0.94. All right, now that's what if you don't know how these are supposed to look, you may have trouble figuring this out. Now, some customers that hadn't owned their cars for very long might complain about elevated idle speeds when they're coasting down. I've had people bring vehicles in and have them written up for that. One person, and this is kind of goofy and it's a little off subject, brought his Thunderbird in. When the newer Thunderbirds came out in 1989, different body style. They came in complaining that when they were using the cruise control, the car would gain speed going down hills. They said our old Thunderbird didn't do this and this one should do it. And I said, well, if you let about half the air out of the tires, this one won't do it. But the cruise control does not apply the brake. Now, it was able to apply the brake on 66 Thunderbirds. They even had a button on the steering wheel that was part of the cruise control that said brake, believe it or not. I never had to work on one of those, so I don't know exactly how it worked. I remember seeing that button on the steering wheel. Well, if the customer notices that there's not much you can do about it, the strategy's built in the PCM, and you're better off just to leave that alone. Now, this is not typically anything you're going to run into nowadays, and if the car is older, it may have some problems you need to look for. Well, the minimum TPS on a Jeep or the closed throttle on a Ford, if you got to determine if what the customer is feeling is PCM strategy or if there's actually a problem that needs to be addressed. Now see this one here, this reading is closed throttle. You notice you got 733 RPM. You're not moving. Look at your TP volts. Both of them screenshots were grabbed from the same vehicle. But you notice how the TP was 0.94 on that previous screen, and on this one it's 0.87. And look at where the idle air control percentage is. See that? Now, a knowledgeable scan tool junkie is going to know idle speed concerns can be generated by a throttle position sensor PID that reflect part throttle even though you've let off the gas. Remember, it's important because a lot of them, there's some of the old throttle position sensors on Toyota and stuff not only had a potentiometer, they also had a switch to tell it whenever you had let off the gas. So it would have an extra wire there for that. Now, the PCM reads and stores closed throttle angle voltage in the RAM at key on and uses the throttle reading to determine when the throttle is at idle or off idle. Now for our story, this is important. This is a Ranger with a problem. Some customers with a 98 2000 Ranger manual transmission might complain of high idle with the clutch depressed that doesn't settle down until it goes into a stop. Now, if they've only recently noticed it, we basically need to go and see if there's something going on there. This one here, now this right here, see what we got here? Again, this thing was hanging up at 0.94 when it was supposed to be, say, at 0.87. That was what it had originally stored. And so when it saw 0.94, when it was looking for 0.87, with your foot off gas, you're going to have a part throttle thing here. That's the reason that this PID is there, so you can tell that the computer doesn't think you've let off the gas. Well, this one right here, in spite of the fact, see, it's not really doing so much crazy thing with the idle on this one. It can in some circumstances, but in this case, this was pretty normal, and that was only a little higher than what it should have been. But this right here and this right here, this little block right here is what you're seeing that indicates a problem. And if you don't know what you're looking at, you'll miss that. So I've seen them do this a few times. All right, if you fiddle with the TP sensor wires with your fingers while watching a scan tool and you see it lower the voltage, then you probably have a connection problem at the sensor. Let's say just watching this thing like this, we see this, and we start fooling with these wires with our fingers and the sensor pushing and pulling on them, and all of a sudden this drops to CT, this voltage goes down, and this shows CT because that's what it recorded when you first started it, and it does it every time you first start it. And so that indicates a problem with either the connectors themselves where they slide onto the pins inside the sensor, or the crimps. Now, we actually had to replace the sensor on this one here, and it didn't change anything. That's what led us to the crimps. And so the poor connection is not usually visible. These look just fine. This is actually on that vehicle that was giving that trouble. And so even with the terminals removed, you're thinking, well, what could be wrong with this? But you got to remember, this is a tiny little whisper of voltage, and it doesn't take any kind of a bad connection at all for it to happen like this. Well, Ford realized there was a problem. They released a TSB on it, and they were basically talking about doing a reflash. That's what they were talking about doing. And so we would flash them, and that didn't change a doggone thing. That was their initial thing. Well, a later TSB came out and said go ahead and replace the pigtail. Now, see, these were the vehicles that were giving that trouble. Poor electrical connection. So they figured, well, you're going to splice into the wire harness and replace the pigtail. And if you got, talk about that again in a minute, but you got pin fit issues, your pigtail may be the right way to go. But if it hadn't been unplugged and unplugged, or plugged and unplugged a lot, then taking those, this heat shrink stuff, if you've got some of that, those butt connectors that have the built-in solder, and they actually have, whenever you stick both the wires in there, they got solder inside that thing, and they also on the outside of it, they got a heat shrink thing. You heat it up, and that solder wicks in there and seals those wires, and then the shrink tubing sucks down around it. That's a good fix. I like soldered and heat shrink mine. But the crimps might be prone to give trouble later on. But if you got pin fit issues, pigtail might be the way to go. Now, oxidation and resulting voltage drop at a sensor terminal crimp can wreak havoc. So we want to fix it right the first time, unless pin fits the problem, and then putting a pigtail on it would probably be the best thing. So if you can't get a replacement pigtail, you can actually, sometimes I've actually been able to pinch those terminals just a little bit very gently and fix a pin fit issue. But they actually have little kits that you can get where you can take a pin like what's supposed to go in there, stick it in there and feel how that, if that pin's got the right kind of drag on it. And you can look at them and see if they're chalked up and, got corrosion and resistance too. That needs to be dealt with. Usually the only way to fix it is to replace the connector pigtail though. If you put these things upright, if you got them dangling, and you do this solder will run up in this connector and you'll never be able to plug it on there again. But if you put the pigtails up and you solder these so that that solder wicks in there real nice and real easy, because that's a clean connection as far as that solder is concerned, that fixes that. Mass airflow sensors, I've seen those do that same thing. My dad had a Tempo he drove, like a 93 Tempo, and it was giving mass airflow sensor issues, and we initially replaced the mass airflow because of the code we were getting. And then I took the unlatched the terminals out of the connector and soldered the crimps like I did on this TP sensor and fixed his Tempo, and we actually had paid for a mass airflow sensor we didn't need if I'd have done the solder crimp thing first. But anyway, everybody needs to decide when is the right time to do this though. But if you've already replaced the sensor and you're still getting issues and you don't see any of the wiring or any trouble, this is a good place to go if you know how to get the connector out of the terminal, out of the shell, because sometimes that's difficult to do. If you mess up the connector shell, then you've got a big problem too, so be aware of that. Now this Grand Cherokee came in for a wheel alignment. The brakes keep pulsating even after I take my foot off the pedal. That's how she wrote it up. Okay. It was initial inspection. We noticed a really high idle, just over 2,000 RPM. We checked the floor mat or anything else interfering with the accelerator under the hood. Didn't find anything obvious. I saw a Jeep one time that came in and the guy was saying, "I'm not driving this until y'all fix it." And he said it tried to run away with him, whatever. And I went out there, it came on the hook. He didn't touch it after it did it. I looked in there and the floor mat was bunched up in front of the gas pedal holding it down. That's all that was wrong with that one. And those floppy floor mats they put in those things from the factory were terrible to do that. Somebody didn't think that through. Well, this one here, when we pulled our codes, we went ahead and got PO 455 code. No joy, it's not going to cause the problem we're having. Don't get caught up on a code that's not, directly related. Now look at the scan tool data stream. The TP sensor voltage was resting above the closed throttle mark on this Jeep, which is what we were talking about before. And the IEC steps were matching the target. So the target, IEC steps, and see the IEC, if you see the IEC shooting for a target that it can't hit, that's one thing. There's even scan tool procedures to check that. But this one here, we didn't have an issue with the IEC not able to reach its target. What we saw was the minimum TPS was 84, and we were getting a 1.37, which is substantially higher. This is a problem here that we need to deal with. So we tapped the gas a couple of times, got it to come back down, and we drove it. Got out there. Well, we didn't feel a brake pulsation, but when we ever came to the stop, it felt like the engine was laboring like you were in too high a gear as the engine slowed down. The transmission, because it was seeing a throttle that was higher than the closed throttle, was holding it in the higher gear. Even after you let off the brake, when you were coming to a stop, it didn't know you were stopping. I don't know why it could look at the idle, the vehicle speed and tell this. But we verified and this, and I said, okay, before we do anything to the transmission, before we go off on a rabbit trail, let's go ahead and replace the throttle position sensor, because we didn't see anything wrong with the pin fit. And I says, the TP sensor is typically going to be the easiest thing to do first. It doesn't cost that much, so I pop one on there. And so the problem with that was one of the screws came out all right. The other one would not budge and busted 2 Torx bits. So we ground the head off of it, took the throttle body off the vehicle, put it in a vise, ground the head off, tried to turn that thing with the vise grips, and it would not move. We put a torch on it, You can see where we scorched it black right here with putting the torch on it. The torch didn't release it. That just boggled my mind. But when we put the heat gun on it, which doesn't seem like it would do as good a job as the torch, although it was heating a larger area, we managed to screw that thing out of there because we used the heat gun. And I mean, that's the only time I've ever seen a heat gun do a better job with something like this than a bottle torch. It's mind-boggling. Heat gun made it turn loose. The TP sensor fixed everything that's wrong with this thing. The transmission didn't labor and cut and, try to stall the engine anymore, and everything was like it ought to be. Of course, we did the alignment too, and they drove away really happy. I hope you got something out of this today. It's been a lot of fun pulling this up and remembering, and the pictures I took and the data that I collected and the notes I took and all that kind of thing. You guys have a great week, and hey, let's be careful out there.